Hi everyone, my name is Timo Walther and I'm a committer in the Apache Flink software project. In these videos, I want to talk and share knowledge about Apache Flink, stream processing, and in general software engineering topics. This video is about Flink and Kafka and the relationship between Apache Flink and Apache Kafka, why those two in a combination are very powerful and super successful used together. First of all, I quickly want to recap what is Apache Flink. Maybe you have seen this slide in one of my other videos. The important piece here is Flink sits usually in the middle of a data processing pipeline. May it be for analytical purposes, ETL, data integration, or event-driven applications. And Flink usually needs to consume and produce data into systems, because Flink doesn't own the data. So usually the data is located in messaging systems or files or databases. And in particular, messaging systems such as Apache Kafka are used often together with Apache Flink. But also let's recap what is Apache Kafka. I'm pretty sure most of you know what Apache Kafka is, but just to be sure that we are all on the same page. Apache Kafka is a distributed event store. So it is possible to store streams of events in a durable and reliable fashion. And Kafka takes care of, first of all, distribute the streams, offer a highly scalable, elastic, and fault-tolerant, and also secure data store for our data in motion. And some people out there also define Kafka as the central nervous system for data in motion. So meaning that Kafka is a very crucial piece in every data landscape for connecting different systems together as a message bus or message queue, however you want to call it. Something that RPC calls can communicate to, that microservices can communicate to, just to wire all these different services together. In Kafka terms, what you usually do is you publish streams, so you write or produce data into Kafka, or you subscribe to a Kafka topic and read and consume data streams from Apache Kafka. Usually we always talk about events, but what are actually events? Events can be anything. In the end, it records a fact that something has happened in the world, in your business or whatever, in your organization. So an event usually consists of those four pieces. An event can have a key. The key is optional, it's not required. The event should have a value usually. The event is also associated with a timestamp, so the event time when something happened. And it has additional metadata. Metadata can be, for example, headers, some headers in the message. Kafka organizes all the data in topics. And those topics are then sub-partitioned into Kafka partitions. You can imagine Kafka partitions just as a bunch of buckets, a number like, I don't know, 6 buckets, 10 buckets, or just one bucket, that allow you to read and write in a parallel fashion to those partitions, to those buckets. Interestingly, conceptually, Kafka is a log. So it provides you with all the features that you would expect from a log. You can use Kafka for a pure append-only log, but you can also use Kafka for an upsert log. So like if you check out the Kafka documentation, you can see that some people are writing null values for some keys, and the null value basically means a deletion of a previously written key. So yeah, with writing null values and having a key, you basically enter the world of updating or upsert streams. So it's up to you and up to the use case how the log is used. Is it a pure insert only, append only log? Or is it a log with some upserting functionality based on a key? So now let's also recap what is Apache Flink. Yeah, Flink, maybe you've also seen this slide in one of my other videos. Flink views the whole world of data processing as kind of a stream. So like streams come in, either the stream is unbounded or the stream is bounded. It's up to you if you want to cut the stream into pieces or where you want to start the processing of a stream. But in any case, also those streams can be considered change logs, right? Like a stream of changes. And even if you just want to perform batch processing, like hourly or nightly batches, even those bounded streams are just a special case in a stream processor. So as you can see, yeah, like Flink basically needs a log or also considers all the data that comes in and out, considers it as a change log. And yeah, let's also look at a typical streaming topology example. Like here, we just have a source, a couple of normalize and filter operations, a join and a sync. Flink is able to process data, consume from a source, process the data and write it out into a sync. And during checkpointing, so performing a snapshot of the whole streaming topology, it is also able to persist the state of each operator, for example, in the state in a join operator or the state in a source operator to a long-term durable storage. So why did I tell you that? Like, why is it so important here in the combination of Kafka? And this I will tell you in a second. So let's really dive into the topic. Why Flink and Kafka? We can view this question from two angles. Angle number one from a Flink perspective and angle number two from a Kafka perspective. Let's start with a Flink perspective. Why Kafka for Flink? As I said before, Flink is just a stream processor. It doesn't own the data. It has no storage layer except for taking care of persisting state. So Flink needs a storage layer and Kafka is just perfectly suited for that. So basically Kafka is the storage and Flink is the processor. And the Kafka connector was actually introduced in Flink 0.9, so at a very, very early stage. And since then, it is the most important connector for the Apache Flink project. And you can see an example here how a Flink job relates to a Kafka topic. So there are various use cases why it makes sense for Flink to integrate tightly with the Kafka topic. First of all, Apache Kafka has a large connector ecosystem. Kafka Connect connectors allow you to connect through ERP systems to various kind of databases and so on. So just offering a Kafka source is super useful for Flink to just access a lot of data systems. And then there is the use case of replaying history. So I showed it in the topology, streaming topology before, that Flink can take a snapshot of the whole topology. But sometimes you need also, so you use this snapshot not only for versioning your streaming application, you also use the snapshot for restoring in case of failures. And in case of failures, we need to roll back the whole streaming topology. This includes also rolling back parts of the input data. So basically, a Kafka topic allows us to replay the history, or at least partially, whenever there are application bugs or node failures. So for example, if there was a bug in your streaming application and your Kafka retention time is 7 days, at least you have 7 days left that you can reprocess to warm up your state or reprocess data of the past days. So a very important component. And this is also shown in this graphic here, in this diagram. You can use Kafka as some kind of queuing or buffering entity between different Flink jobs. So for example, maybe you have a Flink job here that just performs some ETL and stores the normalized data in a Kafka topic. And from there, you can maybe power multiple Flink jobs, right? So multiple Flink jobs can read from this intermediate results in the normalized data and further consume and process the data. It might also be that one of the jobs performs poorly and creates like back pressure. And in that case, the Kafka topic is a perfect queue between Flink jobs. And another important piece here is, maybe you have spotted it already, there is no direct relationship between the number of subtasks and the number of partitions. So both the storage and the processor, they can scale independently from each other. So for example, you can have 10 Kafka partitions, but if just 2 Flink subtasks are enough to process all the data, then you don't need to schedule 10 subtasks. Then 2 subtasks are also more than enough. So let's also take a look at the Kafka perspective. So there are 3 things that where Kafka can benefit from Flink. First one is efficiency, and this is what I also mentioned in the previous slide already. You can scale the processor independent of the Kafka partitions. So if you, for example, have to execute a very expensive task, very computational expensive task, you can just scale out the processor while keeping the Kafka partitions as they are before, right? And also the shuffling during the processing is completely independent of the Kafka partitions. So your data at rest in Kafka can have a completely different key than the data that is processed in Flink. So you can, for example, first group by user ID, but then reshuffle on user ID plus order ID or product ID, or you completely do 2 independent shuffles after each other. The shuffles in Flink don't go through Kafka. So shuffles in Flink stay within Flink. You can only use Kafka when there is a benefit for it, right? Like, as I said, for an intermediate buffer or for an intermediate queue, or if you want to reuse intermediate results. And yeah, just using Flink for Kafka means that you use the most powerful stateful stream processor that is out there on the market. Also meaning you have access to all the different tools, to this giant toolbox of Apache Flink from a Kafka perspective. Expressiveness is a big component to that. You have access to Flink SQL. You have access to Flink's complex event processing library. You have access to Flink's machine learning capabilities and all these different higher level APIs that make the overall Flink experience as it is today. And they can get most of it. They can help you to get most of it out of Kafka. And again, Flink has also a lot of connectors. It's not only Kafka Connect that is shipped with a lot of connectors. Also, Flink allows you to join with other external systems, such as some CDC systems or S3. You can sync into external systems like Apache Iceberg, or you can use the JDBC endpoint connector for Flink. So yeah, like combining both systems, Flink and Kafka together, also broadens your space broadens the space of connectors that you can use for piping data from A to B. So yeah, that was a quick introduction why it makes absolutely sense to combine Flink and Kafka together. And yeah, stay tuned for more videos. Thank you.